Right. So what is the next step now? We have only implemented the transmission part. Now, that means it is like a one-way communication. Microcontroller is transmitting, right?
Yes, sir.
This one is laptop is receiving. That's all. Now, we are going to make a dual communication. Laptop will transmit, microcontroller will receive it, and then the microcontroller will transmit the data back to us. We have to implement that. In order to implement it, what we have to do, we have to enable the receiving part, because those configurations are not done here yet. Right now? Yes or no?
Yes, sir.
So what we are going to do now, first we are going to set up the reconfiguration for reception. For that, here is the documentation. The receiver block diagram is shown in figure 10.4. Data is received on the RC7 RSDT pin, and drives the data recovery block. The data recovery block is actually a high shift register operating at x16 times the baud rate, whereas the main receive serial shift operates at the bit rate of FOS. Only asynchronous mode is selected. Reception is enabled by setting the CREN, continuous receive enable. This bit should be set to what? 1 in order to enable the reception. From which side? Microcontroller side. See, if you transmit something from the laptop, right, that should be received by the microcontroller. In order to enable the reception, you have to set this bit, as we set this bit now, TXEN bit. So you have to set that too. So what I do, initially when it is part of which
Enable means it's referring to one only.
yeah, it is a reference to 1 only, meaning that when you set that to 1, that reception is enabled, that circuit block is activated. If you make this CREN variable value to 0, though there is a reception circuitry, even it gets the data in RX line, it won't digitize it. Do you understand the meaning now? Difference now?
Yes, sir.
Yeah. So what I do, RCSTA, maybe we can make another copy. Instead of disturbing this copy of code, let us create another version. Why for save as it take this much time? Maybe this is overloaded because of this program, I believe. Let me close this program. That's why my laptop fan is running. That is the reason. The moment we close that, automatically it opens this. So what I do, I call this as Sci Tx Rx. Right now, I save that. After that, save. And then I just close this. This card, right? I remove this. Right. Select. So this is that program. In this program, what we do, RC stay bits dot continuous receive enable is equal to 0. Meaning we are setting initially, we said that reception disabled while we initializing the port. Okay. After that, the heart of receiver is receive serial shift register RSR. After sampling the stop bit, the received data in the RSR is transferred to RC REG register if it is empty. If the transfer is complete, the flag bit RCIF in PIR1 is set. If we have a valid data, meaning RSR is transferred to RC. So when we have a valid data received, that is shifted to RC REG. When that happens, RCIF flag is set to 1. The actual interrupt can be enabled, disabled by setting the clearing enable bit RCIE. So which is in PIR 1 fifth bit. I believe we are not going to set that one because RCIE we have disabled TXIE. We are going to disable RXIE as well because we are not we're looking for interrupts. So PIE1. We make that also to 0. Understood? So after that, we made the TX also 0. RX also, RX interrupt also 0. If the transfer is complete, flag bit RS is set. The actual interrupt can be enabled within build. Flag bit RCF is read-only bit which is cleared by the hardware. It is cleared when the the RC REG register has been read and empty. Moment we read the data from that particular bit is cleared. So when it is full, that bit is set to 1. Right? When we read the content from RC REG, then that is empty. RC REG is a double buffered register. It is possible for 2 types of data to be received and transferred to RC REG FIFO, and the third byte begins shifting to RSR register on the deduction of stop bit of third byte. If the RC REG register is still full, the overrun error bit OERR will be set. The word in the RSR will be lost. RCR register can be read twice to retrieve the 2 bytes in the FIFO. Overrun bit OE error to be cleared in software. This is done by resetting the receive logic. CRUN is clear and then set. Understood. So if the bit OE error is set, transfer from the RSR to the REC registers are inhibited and no further data will be received. If it is therefore essential to clear the error bit if it is set. Framing error bit FERR is set if the stop bit is detected as clear. Bit FERR and the 9th receive bit are buffered in the same way as the receive data. Reading the REG will load bit RX9D and FERR with the new values. Therefore, it is essential for the user to read the RCST register before reading the RC REG register in order to not to lose any old FERR and RX9D information. Okay, understood. initialize the SPBR register appropriate baud rate. This is the receive logic. So we already loaded the appropriate baud rate. That has been already done. Enable the asynchronous serial port by clearing the sync bit. Even that is done. If any interrupts are desired, then enable RCRE bit. We are not going to use, so we disabled. Again, we are not using the 9-bit transmission. We will disable that. Enable the reception by setting the CRN bit. We have done that. Flag with RCIF will be set when reception is complete, and an interrupt will be generated if enable RCIE is set. Read the RCSTA register to get the 9th bit if enabled and determine if any error occurred during reception. Read the 8th bit received by the data by reading the 8 bit. Read the 8 bit received data by reading the RC/REG register. If any error occurred, clear the error by clearing the enable bit CREL. If using interrupts, ensure that GIE, PEIE, INCON are set. So as of now, we are good to go. We are good to receive. We have set all those things. Only thing is we are not setting the RCSTA. So what we have to do now? When we come inside the while loop, we will read RC if RCSTA. So we are checking whether any OERR, right? Read RAS to get the 9th bit if enabled, determine if any error occurred during reception. So this OERR will be set to 1 if there is a error. So RR equal to if we are resetting continuous receive enable. So we set that to 0 and then one, right? This we have to do if there is an overrun error. And when we come inside, after doing the initialization, we have to enable CSTA bits continuous receive enable equal to 1 right now. So after doing it, we come inside and we check this one whether we have any overrun error. After that, we have to look for receive flag. The heart of the receive register is receive serial shift register. After sampling the stop bit, the receive data in the RSR is transferred to RCREG register if it is empty. If the transfer is complete, flag bit RCIF is set. Right. The actual interrupt can be enabled, disabled. Okay. Now we have to check which is cleared by the hardware. It is cleared when the RCR register has been read and empty. Okay, understood. So what I do, I just come here and check if while RCSTA it is part of which register PIR1. As long as it is 0, we just wait, meaning we can do like this as well, right? If it is set to 1, then we read the content. Which one? Right here, we just read the content. You can say int data, and say sign data equal to 0, then delta equal to RC REG, right? So we will get the data. If that is, sorry, I think I have to wait as long as it is 0. If it is 0, if it is 1, which means that the data is filled. Once it is done, I read the data. After reading the data, maybe I have to check this first. Right. So we have to do 2 times data equal to RE because it is double buffering. After reading it by 2 times, what I do, I just transmit the data back to data back to the laptop. So what will happen means if I type something now in the Teratom, that it will read it. After reading it, and it will send it back to laptop. So I can see what I type in the laptop now in the screen of the Teratom. Yes or no? Understood the flow now?
Yes, sir.
So here what we do, we do all those initialization. We come here and look for RCIF bit. If that bit is 0, we wait because reception is not completed. Once we get the reception, just what we do, we check is there any error. If there is no error, then we read the content to data 2 times. After reading the data, we check for transmitter availability. If the transmitter is enabled, we just put the data to the transmitter so that it will transmit the data. So let me save this and then go to production, build main projects. One warning. Why? Unsigned into unsigned care. Okay, thank you. So what I do, unsigned care. Done. So now again I turn off the board, remove the controller, connect it to flasher. Now I open flasher program and I just read. It's reading. Once I got it, I want to erase that. Erase. After that, I write the empty words. Then I load new hex and then I write it. Perfect. It is over. Now I remove the controller and connect it to the board. I turn on the motherboard now. So, and then I open Terratom. So previously we got something, a continuous transmission from the motherboard. That won't happen now. It will wait for our input. So I press T here. When I press T, I get the T in the screen. But if I turn off the motherboard, I think I turn off the motherboard now. Now only the transmission part from the laptop will work because the receiver is disabled and it is disconnected from the power. I press T, I'm not getting it. Why I am not getting it? Because no one is there to receive it and echo back. Now I turn on the motherboard now, right? And then I press T, it is coming. I press whatever word that is doing. From this, what happens now is a loop back happens. Whatever we transmit from the laptop, that goes to microcontroller.
Okay.
Microcontroller successfully receive it. Once it receives it successfully, it send the data back to laptop. When the data coming from the motherboard to laptop receive it and show that in the terminal. That is what happens here. To complete this step, we need a complete this motherboard and then a communication cable, Teratom software, everything is needed. So now we have completed the transmission and reception, two-way communication. Understood?
Yes, sir.
Right. With that, I want to stop today's session. We will continue the rest tomorrow.
Sure, sir.
Okay, no?
Yes, sir.
Okay, Vikas. Take care. Bye.
Bye, sir.